Okay, welcome back. This is Dr. Stevens, and we're talking about decision trees. When we left last time, we had Sean on the horns of a dilemma of which job to take, A, B, or C, given that the call for job B just came in, that A or C could come in either order, and that when a call comes in, he either has to accept the job if it's offered or lose it forever. Job A was his favorite, worth 120 points. Job B was his second favorite at 85 points, and job C his least favorite at 60. Of course, the worst that could happen is he doesn't get any job, and that's a payoff of 0. We're seeing the whole tree right here, and that's kind of small, hard to see, so we'll be zooming in on parts of it as we continue to work. The important thing to realize about evaluating or rolling back a decision tree is that we start at the future and work our way back to the present. We'll start out with the last things that occurred and use that information to work back to the beginning. As you can see on the tree, there are two different kinds of nodes. The one of them is marked by a circle. That's a chance node. It means that you don't control what happens. At this one, either company A offers Sean a job or does not. The other kind is a decision node, represented by a square. At a square, you get to pick which way you want to go. Here, company C that always offers a job has called, and Sean can choose to accept the offer or to refuse it. Okay, let's see how we can evaluate this thing. We're going to start out by working at the top part of our tree and rolling back from the end back toward the beginning. So we'll start with the chance node right here. Everything's a chance node or a decision node, and chance nodes are always evaluated the same way. Probability times payoff, added up over all the cases. So in this case, that would look like this. 2/3 times 120 plus 1/3 times 60. That's 80 plus 20, or 100. And that value gets written over top of that chance node. What does that mean? It means that if we ever reach this point in the problem, that's your average payoff. That is, if Sean is offered job B and refuses it, and the second call that comes in is A, then on average he'll be getting 100 happiness points. 2/3 of the time he'll get 120 from his favorite job, 1/3 of the time he'll get 60 from his least favorite job. Alright, we can do that again by rolling back to another step, but in order to do this one, we have to know the value here, and that means we have to know the value here. So once again, we're working from the very end of the tree backward. Here's the calculation for here. We're going to take 2/3 of 120 plus 1/3 times 0, and when you combine those, of course, you get 120 times 2/3 is 80 plus 0 gives 80. That value gets written right over top of that next chance node. But now we've got something different. This square here represents a decision that Sean gets to make. He can accept job C and get 60 happiness points, or refuse it and get a utility of 80. Here he gets to choose the one he likes better, and because this is a max program, better means bigger. So we want the 80, not the 60. We're going to indicate that by barricading the edge that's for the 60. That little blockade there means if we reach this point, we're not going that way, we're going this way instead. And I'll write the value of the option that I chose, 80, over top of the preceding node. Alright, can I get back to this point yet? Well, yeah, I can, because half the time I'll make 100, and half the time I'll make 80. So the calculation looks like half of 100 times half of 80, and that of course comes out to be 90. And you know where to write that, over top of that chance node. Look at the next one. It's a decision. If he refuses B, on average he'll get 90 points of utility. If he accepts B, on average he only gets 85. Sean is an EMVer, so he's going to choose the option which is better, and in a max problem, better means bigger, so he will choose the 90. How should we indicate that? Like this, putting a barricade on the accept B branch, and writing the value that we are accepting, which is the 90, over top of that node. I can't roll back to this first node in the tree because it depends on the lower half of the tree. So let's go ahead and do that part, and then we can finish up the problem. Okay. Let's finish this off by doing the bottom part of the tree. Once again, we're going to work from the right to the left. I could work on this upper branch here, or this lower one here. Just for the heck of it, I'm going to start with the one that's further out, the lower branch. You know what calculation should be done here. 0.25 times 120 plus 0.75 times 0, which gives us an answer like this, 30. I have a choice now of either accepting that job and making 60 or refusing job C and on average making 30. I put the 30 over top of that node to remind me of that. 60 is better than 30, so I'm going to barricade the edge that goes to C, refuse C and choose the accept C side instead. That means I'm going to put the value of 60 over top of that square node. Can I roll back to the next node yet? No, I have to have the value for this part and also for this part, and I don't. So I've got to compute the value for this chance node. See if you can figure out the right calculation. It shouldn't be hard. Hopefully you got 0.25 times 120 plus 0.75 times 60, and that works out to be 75. So if job B isn't offered, but the second calls from A, then on average Sean is going to get 75 utility points. Now I can roll back to this chance node back here. 0.5 times 75 plus 0.5 times 60 gives me 0.67.5. All right, very first node. 60% of the time, job B will be offered, and Sean will make on average 90. 40% of the time, job B will not be offered, and Sean will make on average 67.5. We've got one more calculation to do to figure that out, and as you can see, it's 81. That value goes over top of the first node. So we're now in a position where we can say what the entire tree is telling us to do. Let's see what it says. First off, if the job is offered, if job B is offered, then refuse it. If the second calls from A and you get an offer, take it, otherwise take job C. If on the other hand, the second call is from C, and if it's second call from C, don't take the C job, take A if it's offered, otherwise you end up unemployed. How about if the job B is not offered? If job B is not offered and the second calls from A, then if they offer you a job, take it, otherwise take job C. If B is not offered and the second calls from C, don't take the chance. Go ahead and accept job C. That's a pretty complicated strategy, but it ends up with Sean making on average 81 utility points. That's the best he can do.